All right, what we want to have a look at here is conservation of angular momentum and conservation of energy. Now, or we should show you at some stage, the old skater out there skating, right? And she's got her arms out and she's spinning around really fast, right? So she's got a really big omega. Now, the point is, and we can work out, if we've got an I for the girl, we can work out the angular momentum is equal to I omega. And we've got this theory that says that if there's no external torques operating, and then there can be no change of angular momentum in the system. So we say, okay, the girl brings her hands in, right? And she changes her I. She changes her I. So I is all about mass distribution. So if you bring some mass closer to the center of rotation, then your I has decreased. So this I over here has gone down, which means your omega must increase. And that's what we see. The skater brings in the arms and she speeds up. Say she, it could be he. And so that's our conservation of angular momentum principle. An interesting thing about this, and you can have a little think about it, is where's the, for omega to increase, for there to be a delta omega over delta t, for that to actually increase, there must be a torque, but it's an internal torque, but there's no external torque. Now, that's not what I really want to talk about. I want to talk about conservation of energy. What about rotational kinetic energy, which we said was 1/2 I omega squared? Now, we just said the I got smaller and the omega got bigger. But with the energy, the omega is related to omega squared. Kinetic energy is proportional to omega squared. Whereas with the omega in the angular momentum, it's just proportional, linearly proportional. So you get conservation of angular momentum. Yeah, the omega goes up, but there's not conservation of energy. If we compare the energy here to the energy afterwards, this one now has more energy. So where'd that energy come from? And that's where we go, well, she must have had to do work. And she did work by pulling. All right.